Alright, several people have asked for a more challenging video when we're talking about rational expressions, so I thought I'd go ahead and do a quick video for your rational expressions quiz. So I call it a quiz style rational expression. So I gave you this worksheet via email, but I'll go ahead and show this video to help out. So I'm looking at number 1 real quick, and I noticed that the bottom of this fraction needs to be factored. So I'm going to go ahead and do that really quickly. So I'm going to do 3n squared and 14. So that multiplies to 42n squared. So I think about things that multiply to 42, and I try a bunch of different stuff, but it turns out that 6 times 7 multiplies to 42, and it also adds to 13n. So let's go ahead and put that in here. So 6n and 7n. And then I'm going to start factoring, so I'll factor out in blue. So I see a common factor of 7 and n, so that's 2, and that's got to be 3n as n then. So if I factor the denominator, I get back to, there's a 2n on top, or excuse me, n plus 2 on top, and the factor on the bottom is a 3n plus 7 times n plus 2, and it looks like, I'll bust out the highlighters here, it looks like this n plus 2 and this n plus 2, those will eventually cancel out, and so I am left with 1 divided by 3n plus 7. Well, I also have to get rid of the denominator, so n cannot be negative 2, because if n is negative 2, then this fraction right here, this denominator will be 0, and n can't be negative 7/3. So this is also a part of our answer. Okay, let's jump over here. This looks a little bit more complicated, but y'all, we can really start factoring out key terms. So I notice in the numerator I can factor out 10, because 10 goes into 30 and 50, and I can also factor out a k. So if I do that, I get 10k times, and maybe I will zoom back in. Sorry about that. I'm not using my pen today. I left it at school and I'm doing this video from home. So 3k, because 10 times 3k is 30k, plus 5, because 5 times 10k is 50k, all over 60k times k times k, because k to the third is just k times k times k. Well, look, I mean, we start to notice that I've got 10 and 60, and those can cancel out. They can reduce as a fraction, and then I've got the k and the k. So I'm going to go ahead and start reducing this fraction. So 10 over 60, it looks like 1 over 6, and then get rid of one of the k's. So I've got just 1 times 3k plus 5 over 6k times k. I just have 2k, so k squared. So you could rewrite that in a nicer way of 3k plus 5 over 6k squared, k squared. But k cannot be 0. So I would say that would be our final answer for this. All I did was factor and simplify the giant ones that I had. So going down here to the addition problems, well, addition is really important because with addition, the denominators of the fractions have to be the same, meaning that this 2 also has to be the same as that. And in order to do that, I'm going to start factoring stuff because I want to see the lowest common factor. I notice here that 18v plus 9 I can factor out a 9. So let's do 6 over 9 times 9 times 2v is 18v plus 1 plus, and then I'm going to do the 4 over 2 thing there. Great. Let's see. Oh, hey, we can even go back and we can get rid of this 4 over 2 because that's just going to be 2 over 1. 4 divided by 2 is the same as 2 over 1. And then I can easily get a common denominator if I take that 9 times 2v plus 1, and I multiply it here. 9 times 2v plus 1, v plus 1, over 9 times 2v plus 1. Okay, so simplifying. So I still have the 6. You know what? It was kind of pointless to factor that, but it wasn't all that worthless. 2v plus 1 plus 18 times 2v plus 1. I gotta be really careful here. So 9 times 2v plus 1. I gotta be really careful here. I think what I'm gonna end up doing is redistributing that 18 into both of those, and I gotta be really careful about that. I am running out of room, aren't I? Let's do this. So I have all of this is going to be over 9 times 2v plus 1. And then I'm going to do 18 times 2v, which is 36v, and 18 plus 1, which is 18. And then I also have the 6 plus that stuff. So the 6 came from here. The 36v is 18 times 2v, and the 18 is the 18 times 1. Oh gosh, this is going to be really nice. So it's all still over 9 times 2v plus 1, and 6 plus 18 gives me 24, and I got 36v plus 24. It looks like I can factor out a 3 from the numerator, from the top of this fraction. I'm going to try and move my work up just a little bit so that I have a little bit more space. So 36 divided by 3 ends up being 3 times 12v plus 24 divided by 3 is going to be 8. All of that over 9 times 2v plus 1. Oh, well 3 divided by 9 is 1/3. So this is 12v plus 8 over 3 times 2v plus 1. I don't know if the answer key has that distributed, but you could distribute it if you want. The big thing is that v cannot be equal to -1/2. So that's the simplified version, and why won't that go? There you go. So the simplified version with my exclusion. That was a pretty large problem to have to address, but it seems like something that we could potentially do or address. All right, another addition problem. Again, I need to make sure those denominators are the same. So what I'm going to do is I'm going to take, and I'll do this in red to start, is I need to take the bottom over here, b minus 1, and b minus 1 on the top. This 4 is in the way, so we've got to multiply by b plus 4 and over b plus 4. Sorry, that big B is in the way. So we'll clean this up. I'm just noticing that, hey, I need to distribute those to each other, and I need to distribute that to those guys. So let's do that all together. So on the denominator, my common denominator now, oh, nice, that's awesome, because I've got b plus 4 times b minus 1. And that's the common denominator for both of them. Well, b times 4, so I'm doing this first one is 4b, so I got 4b, and then 4 times 4 is 16, so plus 16, and then 3b times b is going to be 3b squared, and 3b times negative 1 is going to be, excuse me, oop, that's not a plus, it should be a minus 3b. Okay, I'm going to clean this up just a little bit by combining like terms. Hey, I noticed that I've got a b squared, a couple of b's that can be combined, and then a 16. I'm going to put it in a standard form because I bet you I'm going to try and factor it next. So I've got the 3b squared. I've got 4b minus 3b, so that's just a positive 1b, and then 16, so plus 16. All of that over b plus 4 times b minus 1. And I bet you anything that this numerator is going to factor, so let's try it out. Let's try it out. So I got a 3b squared. Those have to add up to 1b, and this last box is 16. So I'm going to bust out my handy calculator. 16 times 3 is 48. I'm looking for something that multiplies to 48 and also adds to 1b. So 48b squared and adds to 1b. Well, those numbers have got to be really close to each other. So if I do 2 and 24, that's not going to do the trick. 4 and 12, that's still not going to do the trick. And then 6 and 8, but you know what? None of these add to positive b, so it's not factorable. It looks like, it seems like this is our final answer, and when I look at the answer key, yeah, it is. I got to be sure to exclude a couple values. B cannot be 1, and b cannot be negative 4, so make sure that you have those as well. All right, we're trucking along. Subtraction is awfully similar to multiplication. I'm going to look here at number 5, and I notice straight off the bat that this denominator right here has a common factor of 2n, because this one is 2n squared, and 4 can be divided by 2, and n is in it as well. So I'm going to start factoring that, and I like to do that because then I can start to see all of the things that are going to come out. So n minus 3 over 2n. Hey, look, that's going to be part of our common factor, times n plus 2 minus 6n over 2n. Oh, look, I don't need to do much other than multiply this guy by the n plus 2 part. N plus 2. Okay. So I'm going to clean this up. Hey, I've got a common denominator now. I've got this 2n times n plus 2, 2n times n plus 2. So I'm just going to, when I rewrite this fraction, all I'm going to do is write it with a common denominator of 2n times n plus 2. Okay, and then I've got n minus 3 minus, and I have to subtract 6n times n plus 2. And this is where people tend to get messed up on assessments, is that not only do I have to distribute this 6n to both of those, everything in here becomes the opposite sign because I'm essentially taking away that stuff. So just kind of clean it up. I've got to multiply those two together, and I have to multiply it by a negative. So I've got the n minus 3 over here. I'm going to keep the 2n times n plus 2 on the denominator, and I've got subtract 6n squared plus 12n, and then that's going to get a negative associated with it. So my simplified version is going to be n minus 3 minus 6n squared minus 12n all over 2n times n plus 2. Whoa, that is the worst plus sign I think I've done in a while. And then I'm going to combine like terms. So my last step is to combine like terms, which would be n minus 12n is going to be negative 11n minus 3. The minus 3 doesn't have anything to go with minus 6n squared all over 2n times n plus 2. So this is going to be our final answer. I would encourage you to check that this numerator cannot be factored, and in fact it cannot be factored. And if we did factor it, nothing would cancel out, which is nice to know. We got to state our exclusions. Remember that n cannot be 0, because if n is 0, then 2n is 0, so n can't be 0, and n cannot be negative 2. So we got to include those in our answer as well. All right, moving right along. I'm going to put up a big divider here so that I don't have to deal with any of that stuff, and we can even run off the page if we have to. So, again, it's another subtraction problem. I got to get the denominators the same. The denominators have to be the same. So this has got to be x plus 4 over x plus 4, and then this one, that annoying 6 is in the way, so multiply that by x minus 5 times x minus 5, and then I have to distribute. Gotta distribute. All of this has got to distribute. So I've got my common denominator, which is x minus 5 times x plus 4, and then 3x times x. Here, I'll just do it out. So x minus 5 times 3x minus 6 times x plus 4. And remember that negative has to be shared with everything. So when I go distributing, that negative, I can think about it as a negative 6 times x and a negative 6 times 4. I forgot the other side of that parenthesis. Negative 6 times all of that. That's oftentimes a helpful way of thinking about it, but the same denominator. So x minus 5 and x plus 4. It's super tempting at this stage to like cancel them out, but remember we can't cancel because I've got that negative sign. So they can't cancel out because I do have that negative sign there. So 3x times x is 3x squared. 3x times negative 5 is negative 15x. Negative 6 times x, negative 6x. And negative 6 times positive 4, negative 24. And then I'm going to combine like terms. And so that's going to be 3x squared, because there's no other x squareds. Negative 15x minus 16, so negative 21x, and then negative 24. I'd want to factor that numerator. And I'm going to do that off to the side. I'm going to try factoring it. So 3x squared, negative 24, negative 21x, 3 times negative 24. Oh my gosh, that's going to be a huge number. And I'm going to pause my video to test out a bunch of things. So I'm going to pause. It's going to sound like I come back real quick, but I'm going to all of a sudden come back. All right, I paused and I realized that this is not factorable, so we can't factor it. This is our final answer. We've got to get rid of the two values that make our the denominator 0, so we got to get rid of, we have to say x can't be 5 and x can't be negative 4. X can't be 5 and x can't be negative 4, and so that's also a part of our answer. So this is the front side of the page. I think addition and subtraction are by far the most challenging. Factoring is going to be critical as we move forward. In just a moment, I'm going to switch over and do the multiplication and division, which I think is a much more simple process. So we'll show you a few examples of that. All right, so we are multiplying and dividing. I only have 4 problems on this page, which is hopefully kind of nice for you. But we'll start with this one. I notice right off the bat that I'm going to want to factor this denominator. And I'm going to want to factor it because I want to see if I can cancel anything. I notice right away as I examine this problem that I've got an r plus 3 on the numerator and an r plus 3 on the denominator, and it's all being multiplied together. So I'm just going to, I just want to cancel them out or get rid of them straight away, because then I don't have to deal with them again. So equals r minus 6 over, I'm going to factor this at the same time, so I'm going to factor this guy. It would normally come right over, but I'm going to factor it as well. So I can see that there's a 2r that can factor out, and then it's a r plus 5, it looks like. Okay, even though I factored it, it wasn't very helpful, but it can help me know what the denominator cannot be. So I need to be sure to include those values in there, because at one point in time, r could not be negative 3, so r cannot be negative 3, and based on what I see here, if 2r is 0, then the denominator is 0, so r cannot be 0, and then again, if r is negative 5, then the denominator can't be 0, so r can't be negative 5. And this is actually the simplified version, and these are my exclusions. So that's why I say multiplication is a lot faster. It only took about 2 minutes to do this one problem, which is nice. So again, let's look at number 8. I notice right off the bat I can factor that numerator, which is going to be really helpful. And I can't quite cancel that p plus or p minus 1 and that p minus 1 because they're on the same. They're both on the denominator. They don't make this giant 1. So my first step in solving this problem is to factor the numerator on the left-hand side. So if I do that, I see that there's a common factor of 3p. So 3p times 3p times p is p squared minus 1. Oh my gosh! Hey, look at that. P minus 1 times 1 over p minus 1. Check it, it's a multiplication problem, and I have a p minus 1 and a p minus 1. That's going to be super handy because they multiply to 1, and 1 times stuff is stuff. So I'm left with 3p times 1, well 3p times 1 is 3p, over p minus 1. So this is as simple as it gets. And it looks like my denominator only has one exclusion because p can't be 1, because if p was 1, then the denominator would be 0. Again, this only took me about a minute to do, and it's a multiplication problem. I didn't need to worry about a common denominator. Like over here, I didn't worry about a common denominator because it was a multiplication problem. Here, again, I don't need to worry about the denominator being a common one because eventually I canceled out, and I just multiplied 1 times 3p, so 3p, and p minus 1, oh, those got canceled, so I just had the p minus 1 that came down as well. All right, division, our key with division is keep it, change it, flip it. And so I keep the first fraction, I change the sign from from division to multiplication, and then I flip the last one. So I'm going to always do that first before I even try canceling stuff out. So I see 6m, keep it, 5m to the third minus 20m squared. Change the sign to multiplication and flip it. So it's m minus 4 over 1. Sorry, my writing isn't so good today. I'm not using my regular pen. I also notice, and hopefully you should too, that hey, this denominator has common factors. 5m cubed, and 20 both have 5s as divisors, and there's an m cubed and an m squared. Oh, I should write that. That's an m. Excuse me. That's an m. Oh goodness, what I do without my pen. So I'm going to factor this denominator. So I'm going to pull out a 5. I'm going to pull out a 5. It looks like 5m squared is common. 5m squared times m gives me 5m cubed, and then minus 4, or negative 4, gives me 20. Oh my gosh! So 6m times m minus 4. I'm doing the multiplication here real quick. And all of that denominator times 1. Oh, I got my m minus 4 and my m minus 4. That's super nice because they cancel out. And I'm left with 6m over 5m to the second power. Well, hey, what's 5m to the second power? That's just m times m. So I got 6m times 5 times m times m. I've got another thing that cancels out. I'm left with 6 over 5m. Now I got to get rid of all of the things that could have made my denominator 0. What were those? So I go back and look. This 5m cubed minus 20m squared, and this factor version 5m squared times m minus 4. Oh, well, if m was 4, then the denominator would have been 0, so m cannot be 4. And then here, that 5m squared, if m was 0, then that would be 0. So m can't be 0. And so we've got our simplified version with my exclusions. The key to this was just like a multiplication problem, except I kept it, changed it, flipped it. So really, I'm giving you another example of multiplication here as well. So notice, I took this, kept it, changed the sign, flipped it, then I factored the denominator and multiplied, and I just multiplied the numerator, so 6m times m minus 4, so 6m times m minus 4. And then I noticed, hey, when I factored the denominator, I could cancel out. And when I expand this m squared, I can cancel out another m, and I'm left with 6 on the top, and 5 times m is what's left over, and I wrote my exclusions. So this is the last one. It's very similar to what we've got here as well. There's one trick to it that's kind of an advanced move, but I think you'll see once I do it what's happening. I am going to start with factoring that, or keeping it, changing it, flipping it. So I've got 5b squared over b minus 2 times, change it, and then I'm going to flip it, 2 minus b over 6b squared minus 36b. All right. I don't need a common denominator, but I noticed that the denominator over here, that I can factor out a 6 and a b. So I'm going to do that really quickly. So I'm going to keep the 5b squared, b minus 2 times, I'm going to keep this 2 minus b over, and I'm going to factor out a 6b. So 6b times b minus 6. Well, as much as I wanted to do that, sorry, this first guy is a b. That's a b. B's and 6's are hard to differentiate from each other. So b minus 6. And it's so tempting to cancel these out. B minus 2 and 2 minus b. Well, I can actually factor that. And I can divide everything or pull out a negative 1, which is something I can do. I can also expand this b squared to b times b. And so I'm going to go do that. So you can start to see the value of expanding things as much as possible. So 5 times b times b. I'm going to factor out a negative 1. So negative 1 times negative 2 plus b. That looks really frustrating because I can do that because if I do negative 1 times negative 2, it's positive 2. And negative 1 times and positive b is negative b, so I'm essentially just pulling out that negative. all of that is being divided by b minus 2 times 6b times b minus 6. This got really messy really fast. But notice I've got a b and a b, and those are multiplied, so I get rid of those. And I can reorder the multiplication here. So instead of negative 2 plus b, I'm going to just flip the order, and it's going to be positive b minus 2. Okay, so I'm rewriting it. That's all I'm doing at this stage. So this is equivalent to 5b times negative 1 times b plus 2. Excuse me, it's b minus 2. Minus 2. Just reordered them all over b minus 2. Oh, look at that. That's going to cancel out. I'm left with the 6 still, times 6, and the b minus 6. This is my fancy 1, and I'm left with 5b times negative 1, so negative 5b over 6 times b minus 6. And that's as simple as it gets. The trick here, I think, in all of this problem, the trick here was that I had to realize that I could factor out a negative 1 to get that, and realizing that b squared is really b times b. And that gets me the things that I can cancel out, and if I swap those, it gets me that. Well, this is riddled with things that can't be 0. So I'm going to look through. B couldn't be 2. B couldn't be negative 2. B can't be 2, and B can't be 2. Oh, hey, same value. So I only really need to write it once. So B can't be 2. B can't be 0 because of this, because when I kept it, changed it, flipped it. B can't be 0, so B can't be 0. And B can't be 6 for the same reason. B can't be 6 there. So B can't be 6. I think that covers all of it. B can't be 2, B can't be 0, B can't be 6. Okay, those are my exclusions, and we've called it good. I know these are challenging problems. Thanks for sticking around. This is a long video, but these are the challenging problems that I expect you to be able to do. So hopefully these are worth your time to even just review or watch what I did. Some of them are tricky, I'm not going to lie, but you need to be able to factor, and when you can factor, you can start to see the things that simplify to 1. Thanks for watching.